Hello, friends, and welcome as we blast off into chapter 4 titled Transformations. And transformation is very important to us mathematically as we move ahead. You're going to transform things next year in Algebra 2 when you're going to take a look at functions and whether it's absolute value functions or quadratic functions, you're going to transform them, and it gets a little bit tricky. So the geometry version of transformations isn't quite as complex as the Algebra 2 version. So it's a nice little transition into this world of a transformation. So now what is a transformation? That's just basically when you take a shape and you either slide it, flip it, turn it. Now these have technical geometric names, but that's essentially what we're doing. Now in the first slide of the notes here, on GeoGebra, there are steps where we can translate or reflect or rotate these things, and we'll take a look at this in class, and I'll walk you through how you can actually, just kind of get a feel for it from a GeoGebra sense and see what's happening. But we turn our attention to the way to transform things by hand in our notes and on our quizzes and things of that nature. So the first section of the chapter is 4.1, titled Translations. And a translation is just a slide. So we're going to slide to the left, slide to the right. Everybody clap your hands. So that kind of stuff. All right? So to perform a slide, or as we call it here, a translation, we're going to use a vector. Now, what is a vector? Vector, very important concept when you guys take physics, when you take pre-calc. A vector is defined as a quantity that has both a magnitude, which is just a size, and a direction. All right? So direction and size. So it's kind of like you want to move something 5 units to the right and 3 units up. A vector is going to be able to do that for you all in one step. And reading here about vectors, very important part of our notes today. This little diagram shows a vector. The initial point, or the starting point, is P. So this thing starts at P, and the terminal point, or where it ends, is up there at Q. So now, how did it get there? Well, from P to Q, we go 5 units to the right, and then 3 units up. And that ends up basically how we go from P to Q. So the vector will tell you how to do it. Now, the component form of a vector is basically telling you the steps to take, and you kind of use a little bracket, and it's not like a parenthesis, it's kind of like a V bracket. 5, 3. Now the first number is the horizontal component. So this tells you to go right or left, and the second, or the vertical component, tells you whether to go up or down. So a positive is going to go to the right on the first number, and a positive will tell you to go up on the second number. If they're negatives, first number is left, second number is down. Bottom paragraph here. A transformation is a function that moves or changes in some way to produce a new figure called an image. And the original figure, where you started from, is called the pre-image. So a lot of vocab on this page, but you're going to see it's pretty easy once we actually start to use it. And what we have here, friends, is the book definition of a translation. It moves every point of the figure the same distance in the same direction. So that's where your vector's coming in. You're heading the same distance, the same direction. And a translation we think of as a slide to the left, or slide to the right. And I added some notes in here from our textbook that actually weren't in our textbook. So, because it gets kind of confusing. When you see P, like a normal letter P here, is where the figure begins. That's the pre-image. And then P prime, when you see that notation, that's what they refer to as prime, and that's kind of where the figure ends up. And we call that the image. So you have an image of where it ends up and a pre-image where it starts. And the prefix there should help you out. The pre-image is the beginning. All right, so now in the first example, we're going to identify vector components. In the diagram, name the vector and write its component form. So I'm looking at this vector. Well, the arrowhead is always where it ends up. So the point that does not have the arrowhead, that's going to be where the vector starts, and that's the letter you have to use first. So JK with a little arrow on top. So that would be the name of this vector. And again, it's like array. It's different than KJ. KJ would tell me to start at K and move towards J. So the name of the vector is JK. And its component form. All right, now for this, it's just like, what did it do? How did it get from J to K? So I went 1, 2, 3, sliding to the right. So you always go left to right first. And then 1, 2, 3, 4 up. So it's positive in both directions. It went to the right and it went up. So it's positive 3, positive 4. So that's a component form of vector JK. Cool thing about vectors, it doesn't matter where you put them on the coordinate plane. If I tell you to start at 0, 0, then you would go to 3, 4. All right, that's cool. But you don't have to. You can start anywhere you want on the coordinate plane. As long as you go 3 units to the right and 4 units up, then bada bing, you're good to go. Second example. And this is what you're going to use a vector for, using a vector. The vertices of a triangle are listed here, A, B, and C. Translate A, B, C using the vector. Aha, so now it's telling you to slide it. So when I see this is telling me 5 to the right, and that is telling me to go down 1. So 5 to the right, and then down 1. So I take all the x values, and I'm going 5 to the right on those. And then I'm going to take a look at the y values, and I'm going to go down 1 to all of those. So you don't even need to graph it. That's the cool thing about these, is you could just be like, all right, well, A prime, the image, add 5 to all of your x values. So if you want to do it like this first, you can. Doesn't matter. Add 5 to that. Add 5 to C's x value. So you got that going for you. And then subtract 1 from all of your y values. So 3 becomes 2, 4 becomes 3, and 0 becomes negative 1. And that's it. That's the translation of this triangle that would move, the whole entire thing moves 5 units to the right and 1 unit down. And it's pretty easy to check your work when you're looking at it. So you got A, 0, so double check. So did we go 5 to the right? Oh yeah. And did we go down 1? Yes, indeed. So this thing would start at 0, 3. A would start at 0, 3. It would slide over to 5 and down to 2. So that's A prime. So this is the image that you've created. The pre-image is where you started. All right, now, so that's a component form. You can also express a translation along the vector using a rule. And the rule is a notation that looks a little something like this. Don't freak out, it really means the same thing. It's just a lot more going on. X comma y heads to x plus a comma y plus b. So we want to write a rule for the translation here in example 3. And let's see, it shouldn't be too bad. You just pick a letter. In this case, I'm going to look at A. That is my pre-image because there's no little prime by it. And A prime is chilling over here. So how did I get from A to A prime? I went 1, 2, 3, 4 to the left, and then up 1. So writing a rule. So in component form, 4 to the left and up 1 looks like that. Negative 4 comma 1. Using the rule for this thing, I just say, all right, x comma y. Turn that into x minus 4 comma y plus 1. Whoop, there it is. So these two things, my friends, mean essentially the same thing. The component form and the rule. So it just depends, whichever one the book asks you for. And it won't matter which letter you pick. C, 1, 2, 3, 4, and up 1. B, 1, 2, 3, 4, and up 1. They all do the same thing. That's the cool thing about these translations. All right, fourth example. Graphing a quadrilateral with the vertices there. The book does it for you. And so there's my pre-image, A, B, C, D. And then its image after the translation. Now, what does this tell you? What does this rule tell you? It says go 3 to the right and then down 1. So all of the points got to do the same thing. 1, 2, 3, down 1. So A to A prime, over 3, down 1, etc. All right? Now, again, you don't have to graph these. You could just kind of look at it. Sometimes the book will ask you to graph them, but that part's pretty easy. And all we're doing is we're going to add 3 to all my x's, and then subtract 1 from all of the y's. So it's a little tedious, but it's pretty easy, so you should be all right. And that's where we're ending up. All right, so we've got add 3 to x's, so -1 turns into 2, -1 turns into 2, 4 turns into 7, 4 turns into 7. Y values down 1, 2 to 1, 5 to 4, 6 to 5, 2 to 1. Whoop, there it is. All right, pause the video here. Try the monitoring progress. See you in a sec. All right, welcome back. Name the vector and write its component form. So in this one, you want to have BK and its component form from B to K. 1, 2, 3, 4, 5 to the left. And up 2. -5, comma 2. Number 2. List the vertices of RST and its image after the translation. So R prime is going to be, let's see, add 1 to the X, add 2 to the Y. S prime, add 1 to the X, add 2 to the Y. And then T prime, add 1 to the X, add 2 to the Y. So there you go. That's it. Fort Pitt. All right. Next, we got some more vocab. A rigid motion is a transformation that preserves the length and the angle measure. All this basically says is you're not going to change the size of these things or the shape. You're just changing the location. A rigid motion is also referred to as an isometry. So when we dilate things later on, we're going to make them bigger or smaller. And that's not an isometry. But anytime you just slide, flip, or spin something, it's going to preserve its length and all the angle measures of any of the shapes that we have. All right, there's an example here of what's happening. So there you go. Whenever we do 2 or more of these combined in a single one, it's called a composition of transformation. So you could do this a couple times. You could slide it and then slide it again. And we'll see later on this chapter that you can flip it, turn it, things like that, along with the slide. So there's a theorem that actually allows us to do this. The composition of 2 or more rigid motions is also a rigid motion. So if you slide something, let's see, our pre-image is here. I slide it with a single prime, slide it again with a double prime. It still maintains its size and its shape. All the angle measures, if there were angle measures, and all the segment lengths. All right, so wrapping up the lesson here today, performing a composition is all you're doing is basically doing 2 steps. You're going to do this step first, this step second. So let's see how it looks like. So when I go R prime, so the X values on the first rule say add 5 to the X's. So I'm going to add 5 to each X. So let's see, 5 to -8 is -3. Then the Y values, I got to drop 2. So I'm starting at 5, I'm going down to +3. All right. And then the S prime, add 5 to the X's and subtract 2 from the Y's. There we go. And then we're shooting it over here to the double prime now. our double prime. Now here's the thing. It's from this point and from this point. So that's where we take our second step. Second step says subtract 4. So I was at -3. Now I'm at -7. Y values drop 2. So drop 2 more. There's our double prime. And then S double prime, from -1, I got to drop 4. So that puts me at -5. And then from 6, I got to drop 2 more. So that puts me at 4. So there would be your image after the composition of translations. All right? So slide it and then slide it again. You don't even need to grab it. All right. Pause the video here. Try this last one. We'll wrap it up. All right. Welcome back. So let's see here. V prime. I started at -6. I add 3. So that puts me at -3. I started at -4. I add 1. That puts me at -3 for that as well. Dub prime. W starts at -3 and adds 3. So that puts you at 0. The Y value is 1. Add 1 to that, and you got 2. Shooting over to the double prime. From the -3, I got to drop 6. And from the Y values -3, I got to drop 4. There you go. And dub prime. Let's see, I was at 0. Drop 6. Puts me at -6. I was at 2. Drop 4. Puts me at -2. All right, guys. So there's the composition of those two translations. And that's a wrap, party people. 4-1 in a nutshell. This is me in a nutshell. How did I get in this nutshell? And peace.